All right, so in this video, we'll be talking through pages 10 and 11 in the notes packet. This is where we are starting to look at linear equations. So just as we did with quadratics, right, where we were looking at standard form, vertex form, and factored form, with lines, we also have three different forms. So we have slope-intercept form, point-slope form, and standard form. And just as with quadratics, right, we can use any three of them to express any quadratic relationship. Same with lines, we can use any three of them to express the same linear relationship. So all of these lines express the same underlying relationship, their graphs are the same. And the most kind of core part of lines is their slope. And so slope is the rate that you change as you go left to right. As you increase x by 1 unit, what do you change y by? And one way you can think about that is the change in y over the change in x, or the rise over the run. So if you go from here, from let's say this point to this point, what is your change in y? Well, your change in y is -3, right? That's your rise, -3. What was your change in x? It's 1. So the slope is going to be -3 over 1, or just -3. And note that you'll get the same answer here no matter what 2 points on the line you choose. So for example, if I choose this line up here, or this point down here, and this point down here, then suddenly I have a rise of -9 and a run of 3. But we know that -9 over +3 is once again just going to be -3. So you get the same slope either way. And not all lines will have integer slopes. So if we look at this one over here, we see that we have a run of 3 and a rise of 2. So our slope is going to be rise over run, change in y over change in x. So our slope here is going to be 2 over 3. And that's totally okay to have a fractional slope. Sometimes we'll just be given points, and we'll need to find the rise in the run, or the change in y and change in x, and we can do that with this formula over here. If you'll notice, the y2 minus y1, you're essentially subtracting the y values of the 2 points to get the change in y. You're subtracting the x to get the change in x. Those correspond to the rise and the run, respectively, so we can take the ratio and find the slope in the same way. So here, we're going to get m is equal to 12 minus 4 over 7 minus 5. So that's going to be 8 over 2, which is 4. So the slope of the line that runs through these 2 points is 4. And then we might also see this formatted in the table, but we can do it the same way. Right? Here's our y1, here's our y2, here's our x1, here's our y2. So we have our 2 points here and here. And we can find the slope in the same way. So m is going to be equal to -7 minus 5 over 5 minus 2. That's going to come out to be -12 over 3, or -4. So the slope of the line between those 2 points is -4. All right, we are going to do the same for all of these here. So this is going to be 8 minus 1 over 2 minus 3. That's going to be 7 over -1, or -7. Here we're going to get 6 minus 1 over -5 minus 9. It's going to be 5 over -14, -5 over 14. Then we can do -3 minus 0 over 3 minus 1. That's going to be -3 over 2. And then here we would get 4 minus 4 over 9 over 4 minus 9. We get 0 over -5, or just 0. All right. And this kind of highlights 2 special cases that we can have with slopes. So sometimes when the slope is 0, notice how that means every 1 unit change in x means there's no change in y, or y just stays the same through all of them. So in that case, we have a slope, right? Your slope is 0, and your equation is just y equals 5. Think about that as y equals 0x plus 5, which is just y equals 5. So it's all of the points that have a y value of 5. We can also have this one over here. And if we tried to do what we did before to find the slope here, we're going to get 6 minus 2 over negative 5 minus negative 5. That's going to become 4 over 0, which means that the slope here would be undefined. Right? We have to have an undefined slope because, remember, the slope is the change in y that is associated with a 1-unit change in x. Well, here, all of the points on this line have an x value of negative 5. So 1, we can write the equation like this to represent all of the points of negative 5. But if x doesn't change, it doesn't make sense to talk about a change in y that corresponds with a change in x because there is no change in x. So that's why the slope there is undefined.